Okay, hello students. In the last class we have discussed few properties of determinants and now we will start with the next topic, adjoint of a matrix and finding inverse of a matrix, especially for 2 by 2 as well as 3 by 3 matrices. These are all important topics. You can expect questions, especially subjective questions from this topic in your boards exam. Okay, what is an adjoint? Let's take this way. Adjoint of 2 by 2 as well as 3 by 3 matrix and inverse of a matrix. Okay, what is adjoint of 2 by 2 matrix? Adjoint of a matrix is nothing but transpose of cofactor matrix. We already discussed how to find cofactor matrix. What is cofactor? Minus 1 power I plus j into mij. What is m? Minor of matrix. So, adjoint is nothing but transpose matrix of cofactor matrix. If A is the 2 by 2 matrix, then what will be adjoint A? Adjoint A is, it is written as ADJ of A. If A is a matrix given by ABCD, then adjoint of A will be what will be adjoint of this matrix? Adjoint of A is cofactor matrix transpose. We already know how to write cofactor matrix. What is cofactor of A? D. We already know how to write cofactor. That is minus 1 power I plus j into mij. This is A11. That means row number is 1, column number is 1. So 1 plus 1 is 2. So minus 1 power 2 is even 1. And here mij, m11 is D. So this element will be D. What is next element? Cofactor of B. 1 plus 2, row 1, column 2. So 1 plus 2 is 3. Minus 1 power 3 is minus. And its minor is C. We will see from here. A matrix is ABCD. Adjoint of A is given by adjoint of A will be D. Adjoint of B is C. As row is 1, column is 2. So this is 1 plus 2 is 3. Minus 1 power 3 is minus 1. So it will be minus of C. So these two elements will get interchanged and these two will change its sign. So what is this? Adjoint of A will be D minus B minus C and A. Who is that? Because when we write adjoint, we have to again transpose this. Cofactor matrix Aij will be D minus C and minus B and A. So then when we take transpose, these two elements will get interchanged as row becomes column and column becomes row. So adjoint of A will be given by what we need to do for 2 by 2 matrix, just interchange diagonal element D and A and change the sign of other elements. Minus B minus C. This is the simplest way to remember how to write adjoint of 2 by 2 matrix. Next, what is adjoint of 3 by 3 matrix? Again, first we need to, for 3 by 3 matrix, again we need to write the cofactor matrix and take the transpose of it. Adjoint is denoted by ADJ, adjoint of matrix A. Now how to find adjoint? Adjoint of matrix is given by, first we will write the cofactor matrix Aij. That is given by, when we write like this, it means capital A denotes the matrix. When we write Aij, that means matrix with cofactor of small aij, that is elements cofactor. This will be given by, what is the value of this? A11, that will be capital A11, which is nothing but determinant of other two elements, minus 1 power 1 plus 1 into that value. Similarly, A12, A13, A21, A22, A23, A31, A32 and A33. Now adjoint of matrix A is given by cofactor matrix, take a transpose of it. Now we will see what is cofactor matrix is given by capital A11, 12, 13, this value. And what is A11? That is nothing but, except leave this row 1 column and take the determinant of submatrix. So this is given by adjoint. What is adjoint? Cofactor matrix is this one. Take the transpose of cofactor matrix. Then row becomes column and column becomes row. This is the adjoint matrix of A. Suppose A is the matrix given by this. Find adjoint of A. Now we will solve this question for better understanding. A is a matrix given by this. Find adjoint of A. Okay. Now what we need to do? Find the elements of cofactor. Cofactor elements, that will be A11, which is given by minus 1 power 1 plus 1 into M11. What is M11? M11, that is given by, M11 is, take matrix of this, determinant of this value, that will be 1 minus 0, that is minus 1 power 2 into 1, which is nothing but 1. Similarly, what is A12? A12 is given by, again first row, second element, A12, that means remaining element, that will be 2 into 1 minus 3 into 0, that is 2, and 1 plus 2 is 3, minus 1 power 3 into 2, 2 minus 0, that is nothing but minus of 2. What is A13? A13 is given by minus 1 power 1 plus 3, that is 4 into M13. Now what is M13? Third column and first row. Leave this remaining determinant. That will be 4 minus 3. 4 minus 3, which is 1. Minus 1 power 4. That is also 1. So A13 is 1. Next, what is A21? A21 is given by, again now leave this, second row, first column. Except this we will have 0, minus 4, and this will be minus sign. So this will be minus of minus 4 will be 4. Clear now? 0 minus 4. This is minus 4. Here 2 plus 1 is 3. So minus 1 power 3 is another minus. Minus of minus 4 is 4. Next, what is A22? A22 is given by second row and second column. Leave this. Remaining will be 1 minus 6, that is minus 5. 2 plus 2 is 4. Minus 1 power 4 is 1. So answer is 1 minus 6 minus 5. I think it is clear now, students. Can you write the other values? What is A31? Minus 1 power 4, that will be plus 1 into, now leave this 2, 3, 1. So third row, first column. Leaving this, remaining will be 0 minus 2. Minus 2. Now what is A32? A32, 3 plus 2 is 5. So it is minus of third row, second column. Leaving this, we have 0 minus 4. It will be minus of minus 4. Now what is A33? A33 is given by, again leave this, third row, third column. Third row, third column. Leaving this, what we have? 1 minus 0. So it will be 1. That is it. So now how to write adjoint? Cofactor matrices, we have to write it as it is. Cofactor matrix Aij is given by matrix of A11, A12, A13, A21, A22, A23. We have calculated A23. Yeah? Okay. So what is A23? A23 is given by second row, third column. Leaving this, we have 2 minus 0, that is 2. It will be minus of 2. Minus 2. Next, what is A31? Again minus 2. A32, 4. A33, 1. Now what is adjoint matrix? Adjoint of A is given by cofactor matrix transpose, which means we have to take the transpose of this matrix. That is equal to, what is the transpose of this matrix? 1 4 minus 2, 1 4 minus 2, minus 2 minus 5 4, minus 2 minus 5 4, 1 minus 2 1, 1 minus 2 1. This will be our adjoint matrix. Is that clear, students? Very easy question, direct question. Find the adjoint of A. Given matrix A. That means adjoint of A is given by cofactor matrix transpose. We have to find the cofactor of each element and make a matrix and then take the transpose of it. That is the adjoint of matrix. Cofactor elements is given by, here we have all the values. Now finally cofactor matrix is given by this. Now take the transpose of cofactor matrix. Take the transpose of cofactor matrix. That is an easy question. Next, what is inverse of a matrix? Again, inverse of a matrix is given by, what is the definition? A matrix has an inverse, which means that inverse multiplied by the matrix itself should give the identity matrix. Similar to how we write numbers. What is the inverse? Inverse of a number is nothing but when you multiply that number with its inverse, it should give identity. Here for matrix, it should give identity matrix. That means for a square matrix A, it's invertible if there exists a square matrix B such that AB is equal to BA is equal to I. I is identity matrix of same order as A and B. Then the matrix B is called inverse of A, or we can also say matrix A is the inverse of B matrix. A matrix is invertible, which means that matrix has unique value of inverse. A matrix has unique inverse, that means we can't have same matrix as the inverse of two matrices. Always matrix inverse is unique number or unique matrix. A matrix is invertible, then A inverse is also invertible. If a matrix is invertible, then its inverse is also invertible. What does it mean? When we take inverse of inverse matrix, it should give the same matrix. Because same property, take AB equal to I, that means B is A inverse. Here B inverse will become A, that means so BA will be equal to I. Both are same. So A and B are two invertible matrices of same type. What is the meaning of this? Same type means same order. Then AB is also invertible. If A and B are two invertible matrices of same order, then AB is also invertible and it is given by AB whole inverse equal to B inverse into A inverse. This is very important, students. Note down this property. This is very important. There is a lot of multiple choice question, 1 mark question, 2 mark question, 3 mark question. All kinds of questions can be asked from this property. This is very important. Now AB whole inverse is given by B inverse into A inverse. What we do? Make the matrix right in reverse and take the inverse. AB whole inverse, that means multiply the two matrices AB, take its inverse, that will be equal to find B inverse and A inverse and then multiply. This property can also be extended to any number of matrices. For example, if we take three matrices, ABC whole inverse, this can be written as C inverse, B inverse, A inverse. If you have n matrices A1, A2, A3 up to An, its inverse will be An inverse, An minus 1 inverse up to A2 inverse, A1 inverse. It can be extended for n matrices. Right, students? Okay. Next is, if A is a matrix given by this is a non-singular matrix. Recall, what is a non-singular matrix? Non-singular matrix is a matrix which has determinant is 0. Sorry, non-zero. Non-singular means determinant is not equal to 0. If A is a non-singular matrix, then A is invertible. Any non-singular matrix, for whichever matrix, if its determinant is not 0, that means it has its inverse. And that inverse will be unique matrix. So A inverse is given by 1 by determinant A into adjoint A. This is the formula for inverse. A inverse equal to 1 by determinant A into adjoint A. Or we can also write this as multiply by A on both sides. Then we will get A into adjoint A will be equal to determinant A into identity matrix. This is the property for inverse of matrix. A into adjoint A will be equal to determinant A into I. This is very important. From this we will get A inverse equal to 1 by determinant A into adjoint of A. This is useful for not just finding inverse, it is also applicable for solving system of linear equations. We will discuss one by one afterwards in the subsequent slides. Now A into adjoint A equal to determinant A into I, that is one important variant of writing this property. Next one is A inverse equal to 1 by determinant A into adjoint A. Proof: if A is a non-singular matrix, then obviously non-singular means determinant is not equal to 0. Let A1, A2, A3, C1, C2 are cofactors of corresponding elements. Then cofactor matrix is given by A1, B1, C1, A2, B2, C2. We already know how to write this. This is A2, B2, C2, A3, B3, C3. This is cofactor matrix. Now what is adjoint? Cofactor transpose. So we are going to interchange rows and columns. A1, A2, A3, B1, B2, B3, C1, C2, C3. Now what is A into adjoint A? A matrix is this one, A1, B1, C1, and cofactor matrix is Cofactor matrix is given by this. Capital A determines cofactor elements. Okay, now what is the product of this matrix? A1 into A1 plus B1 into B1 plus C1 into capital C1. We already know how to write product of matrices. Same way. And what is this element? A1 into its cofactor plus B1 into cofactor, C1 into cofactor. This value is nothing but determinant A. This is nothing but determinant A. And there is another property in determinants. What is that, students? Any element multiplied by cofactor of any other row or column will give 0. So this value, first element will be determinant A, second element is determinant A, third element will become determinant A. This value is determinant of A. This value is again determinant of A. This value is again determinant of A. Remaining elements will become 0. This is 0, 0, 0. All other elements are 0. This is another property, very important property for determinants. You can ask one more question from this. Okay. These elements will be determinant of A and other elements will become 0. So this is determinant A and all other elements are 0, which is nothing but when you take, this is a matrix, so you can take determinant A outside, so this will be determinant A into identity matrix, which is nothing but determinant A into I. That is what we seen in the previous. A into adjoint A is determinant A into identity matrix. A into adjoint A is determinant A into identity matrix. From this, A into adjoint A is determinant A into I. We can divide determinant A. Now, A into some matrix gives I means, that means the other matrix is the inverse of A matrix. So, A inverse will be equal to 1 by determinant A into adjoint A. That is the proof for this. In questions, they may ask, prove that given some matrix A, find the value of A into adjoint A, or prove, verify the property A into adjoint A equal to adjoint A equal to identity matrix, determinant A into identity matrix. Questions can be framed in any way. If A is a square matrix, then A into adjoint A is determinant A into I. A inverse exists if A is non-singular matrix. This is very, very important, students. A inverse only exists if A is a non-singular matrix. Next is system of linear equations. Again, another very important topic, system of linear equations. Now, for solving linear equation, we may use matrix or determinant method. We will discuss how to solve this matrix first. Now, system of linear equation. Consider 3 equations. We will learn to solve how to solve for x, y and z, 3 variables, that is 3 unknowns, and having 3 equations. Let's discuss how to solve for 3 variables, 3 unknowns and 3 equations. That means what we need to find? There are 3 equations with 3 unknowns, that is x, y and z. We should find the value of x, y and z. That is what it means. Solving system of linear equation. Linear equation means its degree is 1. So this entire equation degree is 1. Similarly, second and third equation, we need to solve system of this equation having single degree, and there are 3 unknowns and 3 equations. Okay. The common procedure, standard procedure is to write let A equal to this matrix. What is this, students? A1, B1, C1. This is nothing but coefficient of x, y and z. A1, B1, C1, that is A, B, C. A2, B2, C2. A2, B2, C2. A3, B3, C3. This is nothing but coefficient matrix. A is also called coefficient matrix. A matrix is called coefficient matrix. Next, x. X is nothing but x, y, z, which is nothing but unknowns. This is called unknown matrix or unknowns. Now when we multiply these two, we already know how to multiply. First we should check the order of these matrices and find the order of product. What is the order of this A matrix? That is 3 cross 3. What is the order of X matrix? That is 3 cross 1. Can we multiply these two matrices, students? Yes, we can multiply. We should cancel out column of first matrix and row number of second matrix, and the resultant first matrix row and second matrix column will be the order of resultant matrix. So resultant matrix will have order 3 cross 1. B matrix is of order 3 cross 1. So what we observe is, when we multiply these two matrices, it should equate to B matrix, constant matrix. This B matrix is also called constant matrix. Constant matrix. Okay, now so from this we can observe that matrix A, coefficient matrix into unknown, is equal to constant matrix A into X equal to B. We can write this as A matrix into X equal to B matrix. AX equal to B. Pre-multiply by A inverse on both sides. That means A inverse into A into X. We know associative property of matrices. That means A inverse into A into X equal to A inverse into B. So what is A inverse into A, students? A inverse into A is identity matrix. This is I into X, which is again X. X is equal to A inverse into B. That is it. So for finding unknowns, X is the unknown, we need to find X value. This system of solving equations will be very helpful if we have multiple unknowns and equations. Here, for 3 unknowns and equations, this is the procedure. It is applicable for n number of unknowns and n equations. Now, X is equal to A inverse B. Now, what is consistency of system of linear equation? What does it word consistency mean? Consistency means if this system of equations has a solution or not. Consistency means if the system of equation has solution or not, and what kind of solution is possible for this equation. What I mean by this is, if the system of equation has one solution or no solution or infinitely many solutions, there could be 3 possibilities. Either system of linear equations, when you solve that could result in no solution, or it could have one solution, or it could have infinitely many solutions. For 3 degree system of equations with 3 unknowns and 3 equations, what does that equation actually represent? This Ax plus by plus c equal to d. This type of equation represents planes. Geometrically, what it means is, when you have 3 planes, it can intersect at no point, or it can intersect at one point, or it can overlap each other. That means we will have 0 solution, or 1 solution, or infinite solutions. That is what is mentioned by this. So when we have to determine what will be the solution, what kind of solution is possible when we solve 3 equations, that is given by, now this equation again. A inverse is given by, what is A inverse, students? 1 by determinant A into adjoint of A, and when we write A into adjoint of Ax equal to B, Ax equal to B, X is equal to A inverse into B. We have seen in the previous slide, X unknown matrix equal to A inverse into B. And what is A inverse? A inverse is 1 by determinant A into adjoint A. X is equal to 1 by determinant of A into adjoint of A into B matrix. So what we got, students? X matrix is given by A inverse, that is 1 by determinant A into adjoint A into B. Now from this formula we will observe how many solutions are possible for different cases. Okay, if determinant A is non-zero, that means this is a number. When denominator is non-zero, that means adjoint A into B can be a zero matrix or it can be a finite matrix. It can be a 3 by 1 matrix which has any value. Some value divided by non-zero number will always have some value which is unique. We can't have two values which is same now. So when we have a non-zero number in the denominator, that means adjoint A into B will be some matrix divided by some non-zero number. So solution will be unique for this case. That is, when determinant A is non-zero, this system of linear equations will have unique solution. Next one, if determinant of A equal to 0, if determinant of A becomes 0, then what is the possibility? Adjoint A into B can result in 0 matrix or it can be a finite matrix other than 0. And this adjoint A into B is nothing but 1 by determinant A adjoint A into B will give us the matrix. This actually gives us the matrix X, Y, Z. Now what does that mean? This value is equal to unknown matrix. Now if adjoint A into B is again 0 for all the values, that means X, Y and Z are 0. If adjoint A into B equal to 0, that means this number determinant is also 0, which means X value will be 0 by 0, Y is again 0 by 0, Z is again 0 by 0 form, which is indeterminate forms. So when adjoint A into B equal to 0 matrix, that means we will have infinitely many solutions possible, and this may or may not be true for all the times. This case should be considered very carefully. We can't write this adjoint A into B equal to 0 means it is not necessary that it is always having infinite solutions. I will tell you how to find if there is infinite solution or not. For such questions, what we need to do is convert this, all terms will be of 0 by 0 form. So assume one variable Z equal to T and solve two equations. Find X and Y variable and solve any two equations out of 3 by elimination method. You already know how to solve two equations with two unknowns. Just solve system of linear variables with two equations, two unknowns. You already know how to solve. Now assume Z is equal to some value T, which is assume that as some number constant, which means from that you can solve two values, two equations with two unknowns. After solving the two equations, substitute in the third equation to verify if it matches or not, if it satisfies the third equation or not. If it satisfies, that means we will have infinite solution. Otherwise, it does not have infinite solution. It has no solution. This case is very, very important. You have to be very careful with solving this case. So adjoint A into B equal to 0 and determinant A is equal to 0 implies we have to substitute some value Z is equal to T and solve for X and Y. Any two equations, you can take out of the three equations, you can take any two equations and solve for X and Y. And whatever value we obtain, that will be in terms of T, and substitute in the third equation, see if it satisfies the third equation or not. If it satisfies, that means these equations have infinite solution, otherwise it is having no solution. Okay, we will move to the next case. X is equal to 1 by determinant A into adjoint A into B. Now if any one of these values X, Y or Z becomes non-zero, for example X equal to 2, Y equal to 0, Z is equal to 0. That means determinant A is again 0. That means X will be equal to this value, unknown will be equal to some number by 0, 2 by 0, which is undefined. That means this system of equations has no solution. So whenever out of these three variables X, Y and Z, if any one becomes non-zero and determinant A becomes 0, that means this system of linear equation has no solution. And what we can write, when this system any one value becomes non-zero, that means adjoint A into B is a non-zero matrix. So when adjoint of A into B is not equal to 0, this 0 is actually 0 matrix, 3 by 1 matrix, right? So when this is not equal to 0, already determinant A is 0, that means this system of linear equation have no solution. I think this is clear and it is very important topic. Okay. Next, we will solve one example for this. Solve the following system of equations by matrix method. Okay, there are 3 equations with 3 unknowns. Now what is the step, students? First step is to write the matrix A, which is nothing but coefficient matrix. What is the coefficient? In the first equation we have 1x minus 1y 2z. Next 2x minus 1y 3z. Next 3 2 minus 1. What is X matrix? X matrix is nothing but there are 3 unknowns x, y, z. And what is B matrix? B matrix is given by 7 12 5. 7 12 5. Now what is X? X is equal to A inverse into B. A into X equal to B. Write the matrix here. A into X equal to B. 1 minus 1 2. 2 minus 1 3. 3 2 minus 1 into X Y Z equal to B matrix. 7 12 5. Next, what is the step? X is equal to A inverse into B. X is equal to A inverse into B. Now we need to find A inverse. What is A inverse? A inverse is equal to 1 by determinant A into adjoint of A. 1 by determinant A into adjoint of A. Okay. Now what is determinant A? Determinant A is determinant of this matrix. 1 minus 1 2 2 1 2 minus 1 3 3 2 minus 1. Find the value of this determinant, that is equal to, we can expand by row 1. So 1 into minus 1 into minus 1 1 minus 6, that is minus 5, minus of 1 into, that is minus of minus 1 into remaining minus 2 minus 9, that is minus 11, plus 2 into 4 plus 3, that is 7. So what is the answer, students? Minus 5 minus 5 minus 11 plus 14, that is equal to, this is minus 16 plus 14, which is minus 2. Now determinant A is non-zero, right? Determinant A is non-zero. What is the condition? When determinant A is not equal to 0, that means this system of linear equation will have unique solution. That means a single value of x, y and z is the only solution for this system of linear equation. Only unique solution is possible. Okay, now we have to find for x, y and z. Okay, now what is A inverse? We already know determinant A. We need to find adjoint A. Adjoint of A is given by, find the value. We will see with solution because we already know how to find adjoint matrix. I will directly go to solution and check the adjoint matrix. So A inverse, first find A into x equal to b, find the determinant value. Determinant value is minus 2, which is non-zero. So this system of equation have unique solution, and its solution is given by x equal to A inverse into b. Now what is adjoint matrix? Cofactor matrix transpose. So what do we get, students? Minus 5, 3 minus 1. We will write directly. Minus 5, 3 minus 1. What is the next one? 11 minus 7, 1. 11 minus 7 1. Next one 7 minus 5 1. 7 minus 5 1. This is the adjoint matrix. Now what is solution? X is given by 1 by determinant A into adjoint A into B. Now what is adjoint of A into B? Adjoint of A into B matrix, that is equal to minus 5 3 minus 1 11 minus 7 1 7 minus 5 1. This matrix into what is B matrix? 7 12 5 7 12 and 5. Now this is equal to, again this is 3 by 3 into 3 by 1. Result is 3 by 1 matrix. So what we get? Minus 5 into 7, that is minus 35, plus 36, 12 into 3 is 36, so it is 1 minus 5, which is minus 4. Next 11 into 7, 77, minus 12 into 7, that is minus 7, plus 5, that is minus 2. Next 7 into 7, 49, minus 60, that is minus 11, plus 5. This is the answer. Now what is x from this? X is given by 1 by determinant A into adjoint of A into B matrix. Now what is adjoint A into B? This matrix. That is equal to 1 by minus 2, that is minus 1 by 2 into matrix minus 4, minus 2 and minus 6. We can cancel out minus and divide by 2, which is given by 2, 1 and 3. So what is the value of x, students? 2. Y is equal to 1. Z is equal to 3. This is the solution. The answer is x equal to 2, y equal to 1 and z is equal to 3. Easy question. X equal to 2, y equal to 1 and z is equal to 3. This is how we should solve for system of linear equation having 3 unknowns and 3 variables. Again, you can use the same method for 2 variables and 2 unknowns. That is easy to solve by elimination or cross multiplication. We have numerous ways to solve 2 equations with 2 unknowns. But for 3 equations and 3 unknowns, especially using matrix as well as determinants will give us the easy answer. Okay, this is about this chapter, determinants. Next, we will go to the other chapter, continuity and differentiability. Next chapter is continuity and differentiability. Again, another interesting topic which is very useful. It is based on calculus. This chapter is all about identifying graphs, especially for functions. The basic requirement of this chapter is to understand what is a function and knowing different types of functions and what is the limit. These are all prerequisites for starting this chapter. So you already covered what is a function, what is the limit. You already learned in class 11 and class 12 beginning. You already know all this. What is a function, and you learned limits in class 11. So now we will start with continuity. Okay, we will first discuss what is the limit. I will give a brief introduction for that because that is very useful in the chapter and you learned in class 11. So what is the limit, students? Limit is nothing but the tending value, or at what is the likely value of a function, that is called as a limit. It is not the exact value of the function. For example, f of 2, that means function value at 2. When we say limiting value, that means limit x tends to 2, tending to that value, that is x is approaching 2. So from the graph, if you observe, what is the likely value when you approach? You can approach a function value from 2 different directions, which is from left hand side as well as right hand side, and those 2 values are left hand limits and right hand limit. We will discuss with some graphs. It will be easy to understand them. Okay, this chapter is continuity and differentiability. Now, you already know what is the limit. I will explain while discussing continuity itself again. What is a geometrical interpretation of continuity? That means when you say some value is continuous, what does that mean? Continuity means it does not have any breaks. There is no break or split in between the values. Such values are called continuous. It is continuous means it does not have any break. So for a function, for a graph, when we say it is continuous, that means there should not be any break. That means when you draw a curve, that means you can draw this curve without lifting your hand from the paper. So that means it has no breaks or jumps. What is the meaning of break or jump? Jump means function has two different, it is piecewise. It is defined differently at different regions. So such functions are discontinuous functions. When we say continuity, that means we can draw the graph without lifting hand from the paper. So this is a function is continuous in an interval. Geometrically means that the graph of the function in that interval has no breaks or jumps. In other words, a continuous function is a function whose graph can be drawn without lifting the pen from the paper. So you can draw a graph without lifting pen from the paper. Let's discuss some examples. Let's consider these four examples. I will give another example. Let's take E. Okay, we have 5 different examples. Now see which function is continuous and which is not continuous. This one, function E, we can draw this function without lifting pen from the paper. So that means this is a continuous function. It does not have any break in between. In whatever interval the function is defined, in that interval it should not have any break. We are not caring about the other regions. Suppose this function is defined in this region, that means within this region, at what value interval we are considering, in that interval we can draw the function without any break, without lifting pen from the paper. That is it. So this function is continuous function. Yes. This is continuous function. What about this function? Again, you can draw the function without lifting hand. So this is also continuous. Do you understand? It can have any sharp points, it can change its nature, orientation, everything, but we can draw this function without lifting hand. Now what about this case? Again, when we draw a function marking the circle, shading the circle completely, that means the function value at this point is given by this. So again, this function is continuous. Who is that? You can draw this function without lifting hand from the paper. So this is again continuous function. I hope this is clear, students. What about this case? This function is not continuous. Who is that? Because there is a break. There is a split at this point. So this function is not continuous. I think it is clear now. What about this case? Again, this looks continuous, but there is a break here. So at the value, at this point, say this is A, at the value of A, f of A is not defined. When you consider the interval between these two regions, then this function has a break in between. That means it is not continuous. It appears continuous, but the function is not defined at this point. Suppose this function is defined, value of the function is, let's take this point, f of A is given by this value. This is some f of A. That means this function is defined differently, so this is not a continuous function. Okay. Is it clear, students? I will repeat again. This function, first function is continuous because there is no break here. Second is also continuous because there is no break. It can have sharp points, it can change its nature, orientation, everything, but as long as there is no break in the function, as the function is not defined differently, then we can tell that function as continuous function. Now the next case, we have a break here, that means this is not a continuous function. Again here function is defined differently, so at this point function is not defined or defined differently from the limiting value. What is the limiting value or limit of the function? When you approach this function from left hand side and right hand side, it should give the same value, that is limit. Limit of the function will be when you approach the function from left hand side and right hand side, its value should be same from left hand as well as right hand side. That is called left hand limit and right hand limit. This value is not necessarily this value of f of a. That is, when you observe this function, it is approaching this value. Say this is f1 of a. That means this limiting value is not exactly f of a. It is approaching this value, that f1 of a. Again from the right hand side also, when you approach a, x tending to a, this value is approaching f1 of a. That means limit is same, but function value is defined differently. For this case, limiting value is defined differently, because limiting, when you approach from left hand side, it is coming to this value. When you approach from left hand side, it is giving another value. What about this case? It is having same value. When you approach from left hand side and right hand side, it is giving same value. For this case, again it is having same value. For this case, again it will approach, give same value. That means, what is the condition for these three cases? First three cases, when you observe, limit of the function will be equal to value of the function defined at the point. When this condition is satisfied, we can tell the function is continuous. Is that clear, students? I am repeating again. When you observe from these cases, suppose when you observe from left hand limit and right hand limit, those two values are equal. When you can say a function is continuous, that means limit of the function value will be equal when you approach from left hand as well as right hand side, and the function value is also equal to that. What is the limit? Limit means left hand limit equal to right hand limit. The tending or limiting approaching value of the function should be same from both left as well as right hand side. That is, left hand limit equal to right hand limit. Then we can say limit exists. Now what about continuity? For a function to be continuous, limit should be equal. So that means limit should exist, left hand and right hand limit should be equal, as well as it should be equal to the function value. When you see from these 5 cases, that holds true for first 3 cases, and for the last 2 cases it is not true, because in this case function is defined differently, and in this case function is not defined at this point. So from these cases, these 3 are continuous and these 2 are discontinuous functions. So this is how we see continuity, right? It is very easy to understand continuity from graphs. Okay, if the function is not continuous, then we can say it is discontinuous function. If we can't draw the graph without lifting the hand, then that means it is a discontinuous function. Okay, let's consider these diagrams. Now, which is continuous and which is discontinuous function in this? Let's take graph like this. I have already discussed what is continuity. For the first case, it is drawn without lifting hand from the paper. So this is continuous function. First one is continuous. What about second one? Here function is defined differently. And whenever we have shaded circle, that means that point is the function value. Here there is, this value is shaded. So this is giving the continuous value. At this point, function value is equal to this value, orange shaded circle, and left hand limit will be equal to this value, right hand limit will be equal to this value. So limit is changing, that means it is discontinuous function. Okay, next. Definition of continuity at a point. Now, continuity definition can be defined at a point as well as over an interval. Now, first we will see what is the definition of continuity at the point. When you talk about continuity at a point, that means in its neighborhood. When you talk about neighborhood, that means the value that is closer to the given point. Whatever is neighborhood, you already learned what is neighbor. Neighbor means persons who are nearby you. Neighbor family, that means neighbor houses. Whoever is neighbor to your house, living in the neighborhood, that is called neighborhood. Similarly, for a function, when we talk about neighborhood, that means whatever values that is close to the given value, that is neighborhood. So continuity of a function at a point means close to that point the function should be continuous. Then we can say that function is continuous. It should not be over a very large interval. That is what we call, that is what we mean by continuity at a point. So by neighborhood we mean a function is continuous at a point. That means it is continuous in its neighborhood. That is the meaning of it. Okay. A function, real function is defined by f of x is said to be continuous if the following conditions are satisfied. Now what are the conditions? We talk about neighborhood, that means obviously limit will be involved. Why is that? Because limit gives the approaching or tending value of the function. So that means by neighborhood we mean limiting value. So here it is defined such that f is defined at a is an element of the domain of function. It must be defined at a and limit exists finitely. This is very important. Limit should not be infinite value. Then we can say a function is continuous. That means right hand limit, that is x tends to a plus f of x and x tends to a minus f of x, that is left hand limit. Both these values should be same. Both exist finitely and are equal. That is what we discussed from the graph. So when we talk about limit exists, that means both left hand and as well as right hand limit exists and both values should be equal. This is the first condition. Next, the second condition is this value of limit should be equal to function value. This is the second condition. We have discussed this from the graph. We have observed and understood this two conditions from the graph and it is very clear. So what are the two conditions, students? For a function to be continuous, limit should be existing, left hand and right hand limit should be equal. Then we can say limit exists for the function and it should be equal to the function value. So this is the condition for or definition for continuity or continuous function over at a point. Okay, now if at least one of the above three conditions is violated, then function is discontinuous. Again from the graph, I think it is very clear to you all. So a function is continuous means its limit should be equal, limit should exist and it should be a finite number and that value should be equal to the function value defined at that point. Next, if this is not the case, if there is any one condition is violated, that means if limit does not exist or limit exists but not equal to function value, then we can say it is not continuous or function is not defined but limit is equal. That means it is discontinuous. That is what we discussed in the previous graphs. Okay. Next is types of discontinuity. Again very interesting topic. Just now we have covered what are the different possibilities for different discontinuous cases. So we will discuss the types of discontinuity. One is removable discontinuity. When we can say a function is having removable discontinuity, that means we can change the definition of the function at a single point. Consider only one point. If you can change the definition at a single point, then we can say the function is having removable discontinuity. If there is a break in a function and it is defined differently at over different intervals, then we can say the function is continuous and it is having non-removable discontinuity. That is what it means. We will discuss the two cases and I will go to previous slide and again we will see what that means. F of x is said to be removable discontinuity at x equal to a if limit exists and also limit value is equal but function value is not equal. What does that mean, students? Limit exists I will go to this slide. Now when you observe, limit exists and are equal but function value is not equal, then we call that as removable discontinuity. So already we have seen these two are discontinuous functions, and out of these two, what is removable discontinuity? This value is, this type of graph is called removable discontinuity. This is a removable discontinuity function. Why is that? Because limit is same, limit is equal and is a finite value, left hand limit and right hand limit is same, but function is defined differently. And why do we call that as a removable discontinuity? Because we can change the function value definition at a single point. If you can change that to make that function as continuous, then we call that function as removable discontinuous function, removable discontinuity function. That is type 1 discontinuity, removable discontinuity. Why is that? Because we can change the definition of the function only at one point. If you can change only at one point and this value becomes here, then you can tell this function is having removable discontinuity. So if you can change the definition of function from this point to here, then we call that function having removable discontinuity. This type of function is again non-removable discontinuity. It is obvious. We will see with that table. Okay, this is first type of discontinuity, that is removable discontinuity. Second type of discontinuity is non-removable discontinuity. And in non-removable discontinuity, there are two kinds. First kind is if limit is not equal. That is what is done in that diagram. Fourth case, in that limit value is different. That means it is a non-removable discontinuity. Why is that? Because we can't change the definition of function at a single point to make that a continuous function. So such type of function is called non-removable discontinuous function. And this type is first kind. That is function limit is different from both left hand as well as right hand side. So left hand limit is not equal to right hand limit. This is first type. And the second kind of discontinuity is limit is does not exist. Either left hand limit or right hand limit or both do not exist. That means limiting value is not possible for this function. Then we call that function as having non-removable discontinuity. There are two types. One is removable discontinuity, which is the function is defined only at a single point differently from a continuous function. So we can change the definition of function at a single point to make that as a continuous function. Such type of discontinuity is called removable discontinuity. Second type is non-removable discontinuity. In that we have two cases. First one is left hand as well as right hand limit is not equal. That means function is defined differently over a region of interval and the value does not match at a single point. So this type of discontinuity is first kind of non-removable discontinuity, and second one is limit value either one left hand limit or right hand limit or both do not exist. Okay, next, reasons for discontinuity. Why do we call a function having discontinuity? We will discuss one by one. We will consider with this example. Say this is a graph. We will assume this is a graph. is given by this value, that is origin C, B, A. These points are, this is B, C, B and A. We will discuss what type of discontinuity is there in each of the cases. Limit x tends to A. What is the point A? This point. This is the A point. Does not exist. Second one. Limit x tends to A. Sorry, f of x is not defined at x equal to B. F of x is not defined at x equal to B. Third type is limit is not equal. So there are three different possibilities for a function to be discontinuous. Reason for discontinuity. One is limit is not equal. Another one is function is defined differently, or limit does not exist. There are three possible cases. One is limit does not exist. Another is function is not defined or defined differently. Third one, limit is not equal to function value. So in all the cases shown above, geometrically the graph of function will exhibit a break at the point. So whenever we call discontinuous function discontinuity, that means there will be a break in the graph of the function. The graph shown above is discontinuous at A, B and C. Why is that? This graph is discontinuous at A, B and C. We will see the reasons. Which type of discontinuity is at C? Obvious. There is a break. Left hand limit and right hand limit are not equal. That means what type of discontinuity is this, students? This is a non-removable discontinuity and limit is not equal. So it is a first kind of non-removable discontinuity. So this is non-removable discontinuity of first kind. Now what about this point B? Again, this is a discontinuous function, or yes, it is a discontinuous function because at this point B, the function is not defined. At other points, it is defined. So here at B, left hand limit and right hand limit both are same, but function value is defined differently. This point B is different. So what we need to find? Change the definition of the function such that this limiting value is equal to function value. That means this will become a continuous function at this point. So this is a removable discontinuity. So which type of discontinuity is it? It is a removable discontinuity. Next case. Now at point A, what kind of discontinuity is that? Again here, this function is defined differently at A from this point. So limiting value is equal, but function is defined differently. So this is a non-removable discontinuity of second kind. Okay, A value is here. A is here. That means the function is not defined. That means limit does not exist from right hand side. So this is a non-removable discontinuity of second kind. So removable discontinuity, what is the necessary condition? First one is limit exists but is either not equal to f of a or f of a is not defined. That means f of a is defined differently at the single point or it is not defined, but limiting value is same. Those type of discontinuous functions are called removable discontinuity function. That means limit is equal to function value. Consider an example. F of x is equal to, it is defined like this. X equal to 1 means function value is 2.5 and x not equal to 1 means it is defined x square minus 1 by x minus 1. Now what is the limit of this function? We already know how to find limits. This is having, when you substitute x equal to 1, numerator is 0, denominator is also 0. That means it is of the form 0 by 0. So what we need to find? Limit of this function, limit x tends to 1, f of x, this is equal to limit x tends to 1. Now we need to factorize this, x square minus 1, this is a square minus b square form. So what is the formula, students? A minus b into a plus b, that is x minus 1 into x plus 1 divided by x minus 1. Now x minus 1, can we cancel out this? Here x is not equal to 1 is given, but it is very very close to 1. That is what we call about approaching value of the function or limiting value of the function. When we talk about limit, that means the function is not exactly equal to 1. So that means denominator is actually a finite number. It is very close to 1, x value is. So this denominator is very close to 0. It can be 0.00001 or minus 0.00001, whatever value is, which is very close to 0, but it is not exactly 0 denominator. That means here numerator x minus 1 and denominator x minus 1 will have same value. For example, this is 0.001. Numerator and denominator have some finite value which is very close to 0, but still it is a finite number, so we can cancel out these two. So limit x tends to 1, x plus 1. What is the value, students? When you substitute x equal to 1, 1 plus 1 is 2. And here we have x equal to 1, function value is 2.5. So this function is defined by x equal to 1. So what is the graph of this function by observation? It is easy to understand from graph. Y is equal to x plus 1 is the graph of this function. Yes or no? Y is equal to x plus 1. Now y is equal to x plus 1. Now when you substitute x equal to 0, what is the value of y? Y is equal to 1. So x equal to 0, y is equal to 1. Now y is equal to 0, x equal to minus 1. So this graph of the function is a straight line actually. This is a linear function, straight line graph. You already know how to draw graph. Now at 1 this function value becomes 2.5. So let this point be 1. Now at this point it is an open circle because the function value is changed, and at other points limit value is same, that is equal to 2. Left hand and right hand limit is 2. Function value at 1 is 2.5. So this value is 2.5 and this value is 2. Again from the graph we can observe this value is defined, function is defined differently at a single point. That means by defining the function, by replacing this 2.5 as 2, this function becomes continuous. Yes or no? Yes, because limiting value will be equal to function value when we change this 2.5 to 2. Because we are only changing one value at a single point, we are defining the function differently. That means this is an example for removable discontinuity. So graph is like this. At 1 the function value is 2.5, but limiting value is 2. So this function is discontinuous at 1 since limit value is not equal to function value. To make the function continuous, we have to redefine the function value at f of 1 is 2. That is it. Easy. Next is non-removable discontinuity or jump discontinuity. Why is it called jump discontinuity? Because the function is jumping to other place. Right? Easy. You are not jumping. Okay. Now if limit x tends to a plus, that is right hand limit exists and is equal to f of a, then the function is continuous from the right, that is x equal to a. Yes or no? When right hand limit exists and is equal to f of a, that means from right hand side the function is continuous. Limit from right hand side, when you approach a, function is defined at this point, and left hand side it is not defined. Or you can also consider this point is defined and this point is not defined. Both are similar. So that means when you have this point is defined and the function is from right hand side, limit value is equal to function value, that means this type of function is called a right continuous function. Why is that? From this point all the values are continuous from the right hand side. So this is a right continuous function. Similarly, when you define this value at this point, then this will become a left continuous function. If left hand limit equal to function value and is equal to f of a, then the function is continuous from the left. This is called left continuous function. left hand limit is equal to function value. This is a left continuous function. Third is, if right hand limit, left hand limit both exist and are unequal, then the function is having non-removable discontinuity. So what is that? Left hand limit and right hand limit, both these are not defined differently, then this function is having non-removable discontinuity or jump discontinuity. All these cases are jump discontinuity. Okay, up to now what have we discussed? We have discussed how to draw graphs of function, what is a continuous function and what is continuity, what is the limit, how to see if a function is continuous or not, what is the definition of continuous functions, and what are the different types of discontinuities, that is jump discontinuity as well as removable discontinuity. Jump discontinuity means it is having a non-removable discontinuity, and there are two kinds of non-removable discontinuity, and another one is removable discontinuity. So we have seen up to this. Now we will continue from algebra of continuous functions from the next class. And remember, always keep learning and keep growing. Success is yours line by line, and endigu namma tapasya.